Good morning, everyone, and welcome to this lecture. In this lecture, we are probably going to finish this chapter. The only thing that is left is power to finish. Before going on to this, let us have a quick recap of what we had done in the previous class. And in the previous class, we had seen the case of body moving in a vertical circle attached to a string. We had also seen one more case where the body is moving on the inner surface of a circular track. And these two cases were exactly similar, and we had seen the condition of looping in all these cases. What was the condition of looping? The speed at the lowest point must be how much? The speed at lowest point must be how much? For the condition of looping, what was the speed at the lowest point? Condition of looping, what was the speed at the lowest point? Does anyone remember? No one remembers it. Great. No one remembers it. What was the condition of looping? What was the speed at the lowest point? What are you doing, beta? What is everyone doing in the class? Yes? I can't hear you, beta. What was the condition of looping?
Greater than root 5 GR.
Okay, thank God. We remember it. I was about to have a heart attack. Anyways, it is root over 5 gr. That was a body attached to a string. We will do one last case here because that is slightly different. We'll note down that case. And that case is vertical circle of excuse me. That case is a vertical motion of vertical circular motion of mass attached to a rod. Now, what is different here from the previous case? From the previous case, there was string, and in this case, there is a rod. So, what difference does it make eventually? Now, I have a rod. So, the case is similar. This is motion in a vertical circle, but now instead of a string, I have a rod. I have a rod. Let us say the length of this rod is L, and I have attached a bob of mass M to this rod. Now, the difference between the two scenarios is string can only pull, but a rod, it can pull as well as push. So rod can pull as well as a push. So therefore the case changes. The rod can pull as well as push. Therefore the case changes slightly. Case changes slightly. Now What is the condition for completing the loop here? So remember, condition condition for looping here slightly changes. Now why does it slightly change? Because here the tension, I mean, if I call the rod, the force in the rod as tension, this tension can become zero and this tension can become negative. What I mean to say is this rod in the lower half, it is going to pull, and in the upper half, it can, instead of pulling, it can also push. Therefore, tension has no problem here. Tension can become zero. The only condition that we have to satisfy for this case is number one, and only condition, velocity at point C should be greater than or equal to 0. So that is the only condition that is required for looping. For just completing loop, for just looping, for just completing the loop, for just looping, the condition becomes velocity at point C becomes equal to 0. Velocity at point C becomes equal to 0. That becomes the condition of looping in this case. Now, if I draw the free body diagram at point A, now knowing that the velocity at the lowest point is C, I can write the values at all the other points. I hope you remember how I have done this. Do you remember that? Do you remember that table that we had made at the 3 points? And the 3 points that we are concerned are A, B, and C. Now this is velocity and this is tension. Now let me start with the last one because that is what I know. The velocity at point C is 0. Now velocity at point C is 0, and if I draw the diagram at point C for this rod, if I draw the diagram at point C for this rod, this is point C and this is point B. Now, if I draw the diagram at point C for this rod is now no longer pulling it, but this rod has started to push it back. So tension at point C actually becomes equal to minus mg. Minus mg means that it is pushing rather than pulling. It is going to push rather than pull the rod. Now, looking at velocity at point C is 0, I can write from that concept velocity at point A will be root 4 GL and velocity at point B will be root 2 GL. Do we understand this? Do we remember this? Yes or no? I am not getting voices from boys. Do we understand this? Do we remember this?
Yes, sir.
Tension at point A will be 5 mg. This would be 2 mg, and if I subtract 3 from 2, I will get minus mg. At this point, it is pulling. At this point, it is pulling. But at the point C, it becomes pushing. Do we understand what do I mean by pulling and pushing? At point A, it is pulling. At point B, it is pulling. At point C, it is pushing. Do we understand this? Have we noted this down? Have we noted this down, everyone? Then we must also remember at some point this tension changes from positive to negative, or the tension will become zero at some point. And remember this point, it is a very important point. At this point D, at this point D, at this point D, at this point D, the tension becomes zero. There is no pushing or no pulling. And it is at an angle theta. So remember, at point D, the tension in the rod is zero. The tension is changing from pulling to pushing. Remember, the value of this cos theta is 2 by 3. The value of this cos theta, the angle it makes with the vertical, is 2 by 3. Its velocity is root over 2 by 3 GL. These are the two things that you should remember. At which point the tension becomes zero. At point D, the tension becomes zero. The angle is cos theta is 2 by 3, and the velocity at the point D is root over 2 by 3 GL. I will give you 2 minutes to note this down. So that was the last point that we had to see. Motion of a rod, a motion of a mass attached to rod. Everyone is clear with this, or anyone has any doubt, please come up. Do we understand this? Motion of a body attached to a rod, how it is different from motion of a body which was attached to a string. String can only pull, it cannot push, and therefore to complete the circle, the condition was tension at the highest point should not become zero. But in the second case, when we have a rod, tension can become zero. The only condition we have to use is that velocity should not become zero. And based on that condition, the velocity at the lowest point should be root over 4 GL. Have we understood this, everyone? The tension can become zero, and at some point the tension is going to become zero. We have also seen that point. Yes or no? Now we move on to the last heading of this chapter, and which is known as power. Power, denoted by the letter P. What do you mean by power? Rate at which a body does work,
Work done by unit technical.
or the rate at which a body can do work or can give energy or consume energy. If a body has energy, at what rate it is consuming or giving energy is known as power. What type of quantity is power? Do we know this? Yes or no? It is a scalar quantity. What are the SI unit? Joule per second. This is also known as watt. W. Do we remember this? Do we understand this?
Yes, sir.
What are the dimensions of power?
ML2 T minus 2.
What are the dimensions? ML2,
T minus 2. Click the lamp.
ML2.
T minus 2.
You don't know even to find out the dimensions of power. What do I do? T minus 3. These are the dimensions of power. Whenever we talk about power, we talk about two types of power. The first type of power is known as average power. P in a dabba. What do you mean by average power? What do you mean by average power? Average power is total work divided by total time. Average power is delta W total work divided by delta T total time. I'll give you 1 minute to note it down. Well, average power is total work divided by total time. To write total work, you can write it as integral of f dot dr or f dot ds divided by this can be written as integral dt. So you can write it in this fashion also. Total work divided by total time. Do we understand this? Okay. Now, whenever we have average power, we have one more power which is known as, okay. Uh, which is known as the instantaneous power. What would be instantaneous power? Instantaneous power. What do you mean by instantaneous power? What do you mean by instantaneous power? Instantaneous power means power at any instant. Instantaneous power is denoted by the letter P. What is instantaneous power? Yes, can anyone tell me what is instantaneous power?
d omega by dt, sir.
It is not omega beta, it is work. Please don't call it omega. It's work. dw by dt, it is not omega beta, it is work. You understand? W stands for work. It's not omega, it's work. W stands for work. Please remember, W stands for work. Power is dw, small work divided by small time. So I can write it as f dot dr divided by dt, and dr divided by dt is velocity. So I f dot v, this is the instantaneous power. That is what I am talking about. So these are the two formulae that you must remember. One is for average power and the other one is for instantaneous power. Do we understand these two formulae? The average power wala formula and the instantaneous power wala formula. Can I hope that you will be able to remember this?
Sir.
Yes, will you be able to remember this? Yes or no? Now, we have seen that power is dw by dt. Now, as soon as we see that power is dw by dt, I can understand that the slope of work time graph, if I plot work and time, the slope of this work time graph will give us the instantaneous power. Do we understand this? dw by dt means slope. The slope of work time graph gives me instantaneous power. Now, if I write the reverse of it, the reverse of it would be area. The reverse of this would be area. The area of power time graph will give me the work done. So this is the reverse way of writing it. Do we understand this? Yes or no? No or yes? Do we understand this? Yes or no? No or yes? This is how we can find out from work done, we can find out power. From power, we can find out the work done. From work done, we can find out change in kinetic energy and so on. Do we understand this? Yes or no? No or yes? Everyone understands this? Can I give you a problem now? Small one. Everyone has noted this down? Everyone has noted this down? Here
No,
comes
sir.
the problem for
No,
you.
sir.
From a waterfall, water is falling at the rate of 100 kgs per second on the blades of a turbine. The height of the fall is 100 meters. You can take G as 10.
Sir, can you show previous slide?
Find the power delivered to the turbine. What is the power
Sir,
which
can
is
you show previous?
delivered to the turbine? That is the question. Water is falling at the rate of 100 kgs per second from a height of 100 meters. This is the previous
Sir, can you
slide.
slide previous page?
You should move fast. Let me know once you are done. Then solve this question, sir. The question is on the board. Let me know once you have got the answer. You have to find out the power in this case. Water is falling on turbine plates. Height is 100 meters. Rate is 100 kgs per second. Value of G is 10. Let me know what is your answer. I'll give you 2 minutes to solve this. So how are we supposed to do this? Water is falling at the rate of 100 kgs per second from a height of 100 meters. So what is the energy that is? It has potential energy and that is the energy it is losing. So how much energy it is losing? But the rate is given per second. 100 kg is falling per second. So this is the energy lost in 1 second. Energy lost in 1 second is 100 kg per second. The rate at which it is falling multiplied by 100 is the height from where it is falling, multiplied by 10, which is acceleration due to gravity. The energy is mgh, and I have divided it by time. That is all I have done. It is already divided by seconds. You just had to multiply this and you get your answer. And the answer that you get is how much? 100 kilowatt is the answer for this one, and that is how you do it. You just have to find out how much energy it gives in 1 second. That is your power, and that is how you calculate your power. I thought that this question was simple. I did not know that you will be facing problem in solving this. Sad that you have faced a problem. Anyways, this is the next question. All these questions are there. So this is the second question. Everyone understood the first one? This comes the second one. A pump motor is used to deliver water at a certain rate from a given pipe. To obtain twice as much water from the same pipe in the same time, the power of the motor has to be increased to how much? The power of the motor should be made how much? If I want twice as much water from the same pipe in the same time, how much should I change the power of the motor? Yes, how much should I change the power of the motor? I want twice as much water. A pump is going to deliver that water up to a certain height. I want twice as much water. What should be the power of the motor? How much time should I make it? 2, 4, 8, 16. How much time? Anyone? I'll give you 2 minutes to do this. Please let me know once you are done. Just tell me, beta, how did you get 4 times? Okay, so power of the motor. How will I get the power of the motor? How will I get the power of the motor? Just now I did a question for you, beta. Power of the motor, it has to lift certain water up till certain height. It will lift that water up till certain height in certain time. So it is mgh by 2. Time is same. Height is same. G is same. So power is directly proportional to the mass. How much mass I have to transfer. Everything remains same, bacha. Mass has become twice. So power also becomes 2 times. That is the answer. So any question that comes in this category where a pump is delivering power, pump is putting water up till a height, that is how that question has to be done. Please remember it. Please note it. And then we will move on to the next question. I hope that you can do this one. Everyone has noted the second one? Here comes the third one. A force applied by engine of a train whose mass is 2.05 into 10 raised to the power 6 kg changes its velocities from 5 meter per second to 25 meter per second in 5 minutes. It has taken some time. What is the power of the engine? What is the power that is developed by the engine? This is question number 3 or 4. I've forgotten. I'll give you 2 minutes to get it. Remember, you already know the formula of power. You just have to apply that formula and get your answers. I hope you can give me the correct answer this time around. How are we supposed to do this one? Can anyone tell me what is the formula for power? Yes? Can anyone tell me what is the formula of power? Okay, no one knows it. Power is total work divided by total time. I'm finding out the average power here. I have to find out the total work and what is work done. If you go back to the this chapter only, it is change in kinetic energy. So I have to find out the change in kinetic energy and divide it by the time. How do I find the change in kinetic energy? It is half m into v2 square minus v1 square, final velocity minus initial velocity divided by the time. I just put the values. Half into mass of the engine is 2.05 into 10 raised to the power 6 multiplied by final velocity is as you can see 25 meter per second. So this is This is 25 square minus 5 square divided by time is given as 5 minutes. I cannot use minutes, so I have to change it into seconds. This is the answer, my dear friend, that I was looking for. That is the answer that you should have got. I don't know what you were doing, but that is the answer. And the option that is given to me is this one. I don't know whether it is going to come or not, but that is what is given to you. You just have to find out the work done, and you can find out the work done from change in kinetic energy. I'll give you 2 minutes to note this down. Then comes the next question, and this is the next question. A particle is moving with some velocity under the action of some force. You have to tell me what is the instantaneous power developed or applied to the particle. You have 2 minutes to give me the answer for this one. Option C is absolutely correct. Well done. So what do? To find out the instantaneous power, you don't need to do anything. You just need to take the dot product of force with velocity. As soon as you do it, you are done. So just take the dot product. 10 gets multiplied by 5, 50. 10 gets multiplied by minus 3, minus 30. So that becomes 20. 20 gets multiplied by 6, 120. 120 plus 20 becomes 140. And that is your final answer that you get. You can see it is quite simple. Just have to remember the formulae and apply them. Here comes the last question for the day and the chapter also, and it comes on your screen. Now a car of mass m is driven with an acceleration a along a straight road against a constant external resistive force r. When the velocity of the train is v, what is the rate at which engine of the car is doing work? So car is moving with an acceleration a, but at the same time there is a resistive force acting which is constant, which is r. What is the power which is developed by the engine? Your time begins now. 2 minutes you will get for solving this question. Anyone with an answer?
Sir, answer is MA minus R into V, sir.
Okay, so how are we supposed to do this? This is the vehicle, beta. The vehicle is moving on a road. The acceleration is a. Now, whenever we have the acceleration a, I can write the equation that net force acting on this will be equal to m into a. Yes or no? Yes or no? Now there will be two forces acting on it. One will be the force of the engine and one will be the resistive force R. The force of the engine has to be more, only then this will move. So force of the engine minus the resistive force is equal to M into A. So force of the engine is R plus MA, and therefore the power developed by the engine will be R plus MA multiplied by V. Power is force dot V, and that is the answer, my dear friend. You have to find out the power of the engine. So you have to find out the force developed by the engine, and that is how you do any question that comes in this particular category. With this, we come to an end of this particular chapter. This big chapter we have finished. We will now move ahead into the next chapter. And from here, the tough part of physics starts. So don't worry. We will try to wind it up as it comes. I hope you have understood today's class. Take care and God bless all of you. Bye bye.
So take care.